The diagram shows two identical pendula. Each bob is oscillating with an angular amplitude of 3 degrees. At an instant when one bob is at one end position, the other bob is at opposite end position, and these two bobs are crossing one another by going in opposite direction while passing through the mean position. We'll have to find the phase difference between these two oscillations. On first look, we will think that the phase difference between these two oscillations is 6 degrees. But it is not correct, because the phase difference, which is a difference between two angles, is not visible in visible motion. The motion is visible here. In this diagram, the phase difference is not visible. To see the phase difference, to find the phase difference, we'll have to consider circular model. Circular model of SHM. In circular model of SHM, a particle goes round the circumference of a circle with uniform angular speed omega, and will drop a perpendicular from this particle on a diameter of the circle. Let us drop a perpendicular from the rotating particle on this diameter. This point is called the foot of projection, while this particle, which may be called as parent particle, rotates with uniform angular speed. The foot of projection moves with variable acceleration, and the motion of this point is actually simple harmonic motion. Let this rotating particle is here at t equal to 0, and at t equal to t, the particle has gone ahead to this position. Then the phase of the particle at the instant t equal to t is given by this angle. This is the phase of the oscillating particle. Okay, actually the foot of projection is oscillating. The phase of this is this much, this particular angle. This is denoted by phi, and this is the phase of the oscillating particle at the instant t. So phase is an angle which appears only in circular model. Okay, now we'll find the phase difference for the given problem. We'll draw a circular model, and in that we'll consider position of each of these two pendula. At t equal to t, this oscillating body is at its end position here, and at the same instant the other oscillating body, the red one, is at this end position. Okay, in circular model we let the particles rotate anti-clockwise. So this one is going in this direction and this one is going in this direction. This is the position of the two particles, two oscillating particles, two oscillating bobs at the same instant t equal to t. Phase is an angle measured with this, you may call this x-axis. So what is the phase of the blue bob at the instant t? The phase of the blue bob at the instant t is given by this angle. And we can see here that its value is 0. So phi B stands for blue, that is equal to 0 because this angle is 0. And then what is the phase of the red particle at the same instant? It is given by this angle. It is given by this angle. And this angle is phi r. This angle phi r is 180 degree. So at the given instant, the phase of the red bob is 180 degree and phase of the blue bob is 0 degree. Hence, at t equal to t, the phase difference del phi, phase difference del phi equal to phi r minus phi b equal to 180 minus 0 equal to 180 degree. So the point that we must note that in actual visible motion, phase angle is not observed. Phase angle is observed only in the corresponding circular model of the motion.